Given the graph of f of x equals the absolute value of x, shown here on the left, find the function rule based upon the graph of g of x in the form of g of x equals a times f of the quantity x minus c plus d. Looking at this form, based upon the form of a transformation of f of x shown above, notice b equals 1, which indicates g of x does not have a horizontal stretch or compression. And since f of x equals the absolute value of x, f of the quantity x minus c equals the absolute value of the quantity x minus c. This indicates g of x is going to be in the form of g of x equals a times the absolute value of the quantity x minus c plus d. You may also see the equation in the form shown here below, where c is replaced with h and d is replaced with k. Either way, it doesn't affect the final outcome. To begin, let's track the movement of the vertex. Notice for f of x, the vertex is 0, 0. For g of x, the vertex is negative 2, 4. This indicates the graph has been shifted left 2 units and up 4 units. Recall c indicates a shift left or right, and d indicates a shift up or down. Because we have a shift left 2 units, c equals negative 2. And because we have a shift up 4 units, d equals positive 4. Now we know g of x is equal to a times the absolute value of the quantity x minus negative 2, which simplifies to the quantity x plus 2. And then because d is 4, we have plus 4. There's a couple ways we can determine a. One way to determine the value of a algebraically is select any point on g of x except the vertex, perform substitution, and solve for a. But just analyzing the graph of f of x and g of x, we should recognize a is going to be negative because we have a vertical reflection, and we also have a vertical compression, and therefore the absolute value of a is going to be between 0 and 1. Let's first select a point on g of x and solve for a, and then we'll analyze the graph to verify the value of a. Let's go ahead and use the point 0, 3. Using the point 0, 3, we substitute 3 for g of x and 0 for x. This gives us the equation 3 equals a times the absolute value of the sum of 0 and 2 plus 4. Simplifying, we have the absolute value of 2, which is 2. 2 times a is 2a. We have 3 equals 2a plus 4. Next, we subtract 4 on both sides. 3 minus 4 is negative 1, giving us negative 1 equals 2a. Dividing both sides by 2, we have a equals negative 1/2. This indicates the function rule for g of x is g of x equals negative 1/2 times the absolute value of the quantity x plus 2 plus 4. Recall if a equals negative 1/2, we have a vertical reflection as well as a horizontal compression by a factor of 1/2. Let's see if we can verify this graphically. To do this, we'll start at the vertex of f of x. From here, notice if x increases by 2, the y value or function value increases by 2. And now going to the vertex of g of x, again starting at the vertex, if x increases by 2, notice the y value or function value decreases by 1. And a equals negative 1/2 because 2 times negative 1/2 is equal to negative 1. Again, the a value of negative 1/2 indicates f of x has been reflected vertically and also compressed vertically by a factor of 1/2, which our graph does verify. I hope you found this helpful.